here today. My name is Dave Carson. I look after field engineering for a company called DiffusionData. Field engineering being everything pre-sales, post-sales, professional services, the technical part of deploying our production platforms. Today, we're going to talk about multicast in the cloud. So today we're going to talk about, so as some of my peers here have said already, a lot of the capital markets and trading world have invested very heavily in on-premise deployments, and they don't want to be moving anytime soon, but there is no doubt whatsoever that there is strategies being built around cloud migrations. So the first thing we're going to talk about essentially is what is the state of play for multicast data in the cloud. Where do we start with these strategies? How do we facilitate our clients in terms of building that strategy? What are the advantages of having such data in the cloud for the capital markets industries? We'll talk a little bit about the market data challenges of the sheer texture of market data and the challenges it brings when we look at cloud deployments. We'll also look at touch upon data governance and control. How do you control access to the data? How do you make sure you're compliant? And then finally, how do you monitor usage and reporting and so forth of who's using what data? So where do we start? So essentially, our core product is called Diffusion. It is essentially a Java jar file, so it runs on anything with a JVM. And but we also have what we call a gateway framework, which is a product that allows us to pull in data from any protocol into Diffusion, and it acts as both the source and sink. So we can pull in data from any standardized protocol. It could be the H protocol, it could be FixFast for streaming, or any sort of proprietary system, and we can consume data and then publish out to any system as well. So we're talking about getting data into Diffusion, and then we're talking about getting data out of Diffusion. So what these slides are really taking us to is where we're sort of seeing things is, well, our customers have an awful lot of data on premise. They are very carefully working out which applications can be migrated to the cloud. So we're working with the customers to build these adapters to pull their data up into the cloud. Diffusion, as a Java jar file, is of course cloud agnostic. It can run anywhere with a JVM, so we can pull data up into any cloud, we can send data out to any cloud, and then of course we can pull the data back down to any sort of other site. We'll talk about some of the features that Diffusion provides in terms of facilitating this migration. These lines that we see here, it's worth mentioning that Diffusion has a patent feature that we call the compressed deltas. And as I know we're here with a bunch of market data experts, we all know what a delta is. But we do things differently. So a lot of platforms will calculate a delta by essentially taking the message up through the OSI stack into the application layer, and then just perform a field-by-field diff to work out what's the difference. Diffusion does things differently. Diffusion operates at what's called the CBOR level, or concise binary object representation. So we are performing a bitwise or bytewise diff at the CBOR level. So all we actually have to publish into Diffusion are the bytes that have changed. Now, what does that mean? Well, it means that we obviously work well with market data and with the texture of market data and so forth. The only things that are really changing are the top of the book, the prices, the quantities, and so forth, and a timestamp. But it also means we can actually apply deltas to even binary payloads. So we don't have to decode the binary in order to calculate a delta. We can actually perform deltas on binary payloads. But with the texture of market data, we will see almost always upwards of 70% reduction, quite often 80%, and we've even seen 90% reduction in ingress and egress costs. So when we start seeing those numbers in terms of how much bandwidth savings we're talking about, then things like cloud strategies become feasible. So talk a little bit then about, sorry, apologies. So where are we today with support in the cloud? So AWS, it's the only one that provides a component that actually supports multicast, and it's called the Transit Gateway Service. But a little bit about the costs of it is that what does this deployment look like? Well, the only way that you can actually get the data into the multicast form is by using the Transit Gateway attachment. So you need to pay to get the data into the Transit Gateway. You need to pay for actually using the attachment itself. And then you need to pay for every gigabyte out to every receiver. So as I'm sure we all know, with the nature of multicast, it's one out to many. So that does clearly not going to scale very well. That's going to be extremely expensive for market data. On Azure, it's Azure. I think I thought, yeah. Sorry, apologies. On Azure, it is only available through Switch.io or SWX Switch.io. It's a third party, and all it provides in terms of fan out is a simple unicast connection. So there's no intelligence whatsoever in terms of getting all of this data out to the world. It's a simple socket. Anybody can write a socket. On GCP, it's not supported today, and then finally on IBM Cloud, it's not supported today as well. So, what are the advantages for capital markets in terms of moving the market data and so forth up to the cloud? So, first of all, we are going to say, well, how do we evolve the on-premise and then the cloud and indeed the hybrid deployments without having to do a full re-architecture? Do we use the public cloud? In fact, we're actually working with a tier 1 bank who is building their cloud strategy, but the CISO has actually put a hold on it because it's public infrastructure. How can you have clearly private data in public infrastructure? We will facilitate that because every single publisher and consumer, its secure WebSocket is the underlying transport, and it is always encrypted with TLS 1.3. So that's today's most secure standards in terms of encryption. So how do we deliver data across clouds, across availability zones, even across regions? And how do we do it reliably, efficiently, and securely? So I've already touched upon the security element, but we've also touched upon the efficiency element in terms of reducing those ingress and egress costs. But also, since the transport is a secure WebSocket, then the data is delivered always. There's no loss here. There's it's not lossy. And then how do we safely deliver what content is required? So to make sure that the consumers actually get the data, that they don't miss the packets. And also, how do we track what is consumed? How do we know who is using what data when? When do they start subscribing? When do they stop subscribing? For things like exchange reporting. So if we start with the first one in terms of how do we evolve how do we work alongside the existing on-premise infrastructures? So we've mentioned previously that diffusion is a single Java process. We can bring it up on-premise, we can bring it up in any of the clouds, and we can literally start streaming the data between the two processes. It's a simple line. It can be done programmatically. So we can start streaming data based on any event programmatically, dynamically. We can also decide what data we want to stream in terms of maybe we only want to stream certain exchanges across certain regions. Maybe we only want to stream certain content, certain message types. Maybe we only want to stream. We're not interested in pre-trade. We only want the post-trade executions. So we only need to stream the trades. We can define exactly what content needs to be streamed where. Not every customer needs full order book depth. Some are interested in the top of book, top 5, top 10. So we can deliver only the content that each individual consumer requires, or indeed what should be streamed across the different regions as well. So this also allows us to help our customers make sure that they're only sending the data that needs to be sent and is allowed to be sent. So that allows our customers to make sure that they're not sending data to particular regions or different places where that data should not be flowing to. So, and we've mentioned before, we are of course cloud agnostic, being that Java jar file. So how do we deliver data across clouds, across availability zones and so forth, reliably, efficiently and securely? Well, I've mentioned that we're a Java process. The second point here is that every single connected consumer is given its own queue on the Diffusion server. So each consumer is consuming the data at its own rates. And if there is a slow consumer, as I'm sure you're familiar with the old market data transports and so forth, there was always potentially a risk of a slow consumer causing recapping and so forth and bringing down, impacting the performance of other consumers. But since every consumer has its own queue, it will process the data at its own rate. And if it were to be slow, for example, we have different ways like flipping to conflated feeds for that user and then sending them a snapshot or sending one message every 5 seconds, every 10 seconds, let them drain the queue. But crucially, a slow consumer cannot affect the performance of any other consumers. I've mentioned previously about our compressed delta technology, which is patented both in the US and the EU. And we are constantly seeing upwards of 70% given the texture of market data, as I've mentioned. All the activity is around the top of the book or the trades. So since we're only sending what has changed, we're seeing significant reduction in ingress and egress costs. And then finally, as I've mentioned as well, all publishing and consuming is encrypted to the most secure standard, TLS 1.3 today. So how do we safely deliver only the content that is required and then track what is consumed? So Diffusion does things slightly differently from other, messaging platforms. Diffusion allows us as a free form to structure the data in a totally blank canvas topic tree hierarchy. So it might say start with asset classes, equities, futures, options, fixed income, and so forth, FX. Then we might have it under region. And then it's totally up to us how we design this and so forth. And each consumer can subscribe to the relevant part of the tree. So they're only getting the data that it needs. It's not a flat list of instruments where the consumer just subscribes to the flat list. A consumer can subscribe to everything underneath a particular part of the tree. And then as new topics or new instruments are added, that data will immediately start flowing. So they don't need to maintain a list of instruments. So for example, we can create views where all futures and all options for a particular underlying, and then they just subscribe to the underlying and they get everything. One example. So as the options expire and roll, then basically they will just get the new instruments as they become available. Things like this. There's an API with Diffusion which allows us to monitor every client that connects, what they start subscribing to and when they stop subscribing. So this allows us to do things like automated reporting. So we can actually have a process sitting there reporting who is using what when. So for things like if there's an audit being performed, we'll know exactly which consumers were using what data. And we're actually working with third parties today on some, integrating with this for the seamless reporting to various exchanges as well at this point in time. We also, of course, don't have any problems with the likes of packet forwarding and so forth. So like sending data out to where it shouldn't be going to. So what does this mean from the market data perspective? Well, market data volumes are only going one way, and that's up. So given what we've described already around things like where we can structure the tree, we can send only the data that's required. Diffusion also provides the ability to change the texture of the data in terms of what's being published. We can delay the data for those that, for example, if they don't want to pay for real time, but they still want the data. Maybe it's a tick capture database, something like that. So we can delay it by 30 minutes, but it maintains the interspatial differences. So it just looks like a live feed, but it's delayed. We can also throttle the data, or we can mix and match as well. So we can deliver the update every 5 seconds or every 10 seconds, whatever it may be. As I mentioned previously, we can change client subscriptions on demand. We can monitor what each consumer is doing, the size of its queue, things like this, and we can flip them to throttle views of the data and so forth if on the server side. So we can control what data that each client is getting. That is actually a good use case for us in terms of we actually help customers who are trying to tackle scrapers. They're identifying the customers coming in, scraping, for example, a free service of data. We can identify the scrapers and then we can redirect them, say, to a delayed version of the feed. So they think they're getting the real data, but actually what they're getting is out of date. Diffusion allows us to create new content on the fly. By that, what it means, we can aggregate data together. We can disaggregate data, so we can look at the content of a JSON structure, an array, and we can take it apart and make up new topics on demand. All of this is done in flight. All of this is done, it can be done in the middle of the day. We don't have to restart a server to do this. We don't even need to restart the client consumers. We can literally create new content from the data flowing through the platform. We have mentioned that the efficient distribution on our compressed deltas, and then we can bring on new consumers with ease. So we can integrate with any role-based access control system. So we've integrated with Kerberos, OAuth. I recently did one for JWTs. We can integrate with EMRS. We can integrate with DAX and so forth as well. So our customers manage all of their users in one place. We just talk to their system. So that then takes us to the next stage, which is basically about data governance and control. So we've mentioned that we structure data in a taxonomies hierarchy. So only the content that a user is allowed to see is what they get. They can, if they know, they can subscribe to exactly what they're interested in. But equally, the role-based access control system will strictly enforce that. They will not get any data they're not allowed to see. We've mentioned how we centrally control the content of the finest granularity right down to the lowest level topic. We've mentioned we can actually interrogate properties on a consumer in terms of the session. So it might be something like the tier of a customer, tier 1, 2, 3, and we can direct them to different parts of the tree. So we can look for we can cater for a global user base and personalize the data, even though they're just connecting the same as each other. They can get different content, different personalized content. Another example there might be something like country code. We can interrogate a country code of the consuming session, and then we can direct them to the part of the tree for what should be delivered to that session and so forth. And then ensuring compliance, disaster recovery and so forth across zones and jurisdictions, because we're able to stream all of this data and only send the right data to each of the zones. We can basically make sure our customers use us to basically make sure that their DR sites today are always up to date. I myself have worked for many years in investment banks, and I've never seen a DR event pass. There's always been a failure somewhere because something has gone out of date because of the change control or whatever. I'd never made it to DR. But by using Diffusion, we can make sure that the DR site is always up to date. I sort of have gone through some of this already. So we've mentioned that there's an API for tracking exactly who is using what data when they connect, when they start subscribing, and when they stop subscribing. So that allows us to do automatic reporting, like to exchanges and so forth. I've mentioned that we can deploy permissions, change the permission system and so forth in real time, but our customers tend to centrally manage within their own platforms, and we just talk to their permissioning system. Well, I've mentioned this, but sorry, this allows us to deploy the usage monitor, so every client knows exactly who is using what data. So when it comes to things like the cloud, and every single customer will be able to report exactly which customers have used what data. So no more fears of the audits coming in. Again, this is all where with Multicast this isn't always possible. And then we can switch on and switch off data delivery on a per client basis without impacting other clients. So we can literally we can watch what the clients are doing, and we can literally switch off the data and so forth if we need to as well on a per client basis. So in terms of then really just wrapping up, I think, so what does this mean? Where do we start? So we've mentioned that we have a gateway framework which allows us to pull data from any source into Diffusion. We can make use of all of the features that we've mentioned around structuring the data, locking it down, making sure data does not flow to places that it should not go to, monitoring each individual user and so forth, and just all this is about reducing the amount of data that needs to be transported across clouds, across regions and so forth. And we basically have gone through it. So this is our gateway framework. It provides 90% boilerplate code. All we have to do is write the 10% for any adapter. So we can create a niche publisher or a niche consumer, a niche publisher, and we can write to any proprietary internal format as well. So it's and what this means is that every adapter looks the same. So if you've ever worked in a production environment, you'll know that there are different developers have different styles. Some like CSV, some like Avro, different ways of upgrading, downgrading, different logging patterns and so forth. But what the gateway framework provides is 90% standard code. All we have to do is do the translation layer, and everything looks the same. So as we grow the platform, it becomes extremely supportable. And basically, what we're doing here is we convert the multicast protocols. So our customers have their own sites that have invested their on-prem sites which they've invested heavily in. We convert these protocols into Diffusion. We can publish data up to any cloud, from any cloud to any cloud, and we can bring it back down. That new data, that enriched data that we've talked about, sort of transforming the data in flight, we can do all of this inside Diffusion, and then only send the data that's needed back down to other sites and so forth as well. So this allows our customers to start looking at getting the data securely into the cloud. And then they can start looking at what applications that can they move from their on-premise up to the cloud, if you like. And then that takes us just to the very, very last slide, which is basically the 3 layers we have of Diffusion. Consuming from anywhere, any real-time feed, database, Kafka and so forth. We have adapters for Kafka in production today. Transforming the data in flight, structuring it, creating new content in flight and so forth, locking it down. And then that efficient distribution out to the world as well, or out to any other platforms. So we integrate, we structure, transform the data, we deliver it securely to today's most secure standards. Of course, don't forget about those over 70% reduction in ingress egress costs. We operate on-prem, in cloud, or hybrid. We've got our own Diffusion cloud today. You can sign up today for a Diffusion cloud instance. That's running in production for across many clients. All of the APIs we've mentioned that allows us to build platforms for our customers. It's completely open in that sense that we can build. Everything is exposed and transparent. Everything from monitoring the metrics, manipulating the topic tree, controlling the users, and so forth. It's all API driven. And then finally, we have we also, it's pub sub streaming generally, but we also support request response for those that don't need every single update, maybe like a web page or so forth. And of course, we can either have stateless caching or stateful caching if you need the full data. And that takes us to the end.
So what about world peace and climate change? You sold everything else. Sorry, I couldn't resist that.
Sorry.
Questions.
Hi, my name is Kiran from Bloomberg. So you said the subscriber subscribes to a specific topic, right?
It can subscribe to a specific topic, one, or it can subscribe to at any point of the topic tree. So a subscriber could subscribe to the US dollar, or it could subscribe to all FX data, and everything underneath will flow down. So it's up to the subscriber. It also supports wildcard selectors as well. So like regular expressions and so forth. So we could do give me all ISIN codes that begin with US.
I see. Yeah. So how does that work? Like, the reason I ask is if the scale is too big, let's take two large exchanges and then put it into one stream. And if they just subscribe to that single stream, then, is your system overloaded, or how does it handle it?
That's a great question. And actually in October last year in WIFIC in Prague, I actually did a demo of how Diffusion can do automatic scaling. So we can use the APIs that we're mentioning here. So we can monitor any metric. It could be CPU, it could be Java heap, it could be message per second, or client queue size, for example. Anything whatsoever. If it's data, we can monitor it as a metric. We can then use our APIs to spin up a new Diffusion server, and we can then use the topic tree, so forth, to inform the publishers a new service is now available. Start publishing your data to this service. And equally, we can tell the consumers you've now got two services, so we can scale up based upon any criteria we wish. So if CPU hits over 80%, scale up, and then we can scale back down again. Let's when it goes back down below 50%, then we realign everything back to the single server and we scale back down. That means you do not need to have lots of redundant servers sitting there running 24/7, where you're paying for them every day and you only maybe use them, once. The platform can actually scale itself up and then scale back down again when needed.
Actually, I've got a question. It's not a technical one. I mean, Dave, when you were talking about ingress and egress costs, you have come up with a technical solution to get around a commercial problem or a commercial obstacle. And maybe this is a question more at Google or the cloud providers. I mean, are the way ingress and egress costs designed? Were they designed by the by the cloud providers who didn't really understand market data for other situations? And are we in a market data scenario so different to other solutions that ingress and egress costs, I'm looking at you, Matt, as I said this, could they change? Could the cloud providers, I know that takes away one of the advantages you've got, but do you think the cloud providers will change, or do they have to stick with that ingress and egress costs?
I think I would say, and I know we've got cloud providers here in the room today, but we also have banks and so forth, and we've been asked, banks are engaging us to help with their strategies, and the general theme is that we almost all need to get in a room and talk about this, because the data volumes are still going up, but the costing models of all of the clouds and so forth do not lend itself well to getting the data even into the cloud, never mind moving it around the cloud or out of the cloud. So it's really a case of what we've presented here today shows how we can hopefully structure the data and reduce all the costs on the way in, and then reduce only the data that has to go out, rather than sending a fire hose out to everybody. You just send the data that each user needs. So we can facilitate that, but I think the general theme is across the board is that a conversation needs to be had.
The question at the back.
More than a question, I actually wanted to answer your. I'm not a cloud service provider, but I can answer on behalf, right? I mean, usually because I work for banks and we have the same exact problem when I was at Citibank and JP Morgan. The answer is no, they will not, especially egress costs. And here's why. The whole point that they're trying to do is create data gravity. Any vendor, regardless of if it's a cloud service provider or ISV of any kind, they want to create a commercial situation where in the long run their customers stick with them. Right from the beginning, the cloud service providers have always had high egress costs. They want you to bring their data there. They'll actually work with you on the ingress costs. We've been able to work out deals where ingress cost was almost zero out. They would even ship you devices where you can, in your data center, transfer the data onto that device, and then they'll put it into their data center for free of cost. But once you're there, what's keeping you there? The egress costs. So
Interesting.
Agree, 100%.
Oh, one of it.
The problem with that, and you're entirely correct. The problem with that is the fairness problem the SEC is putting in there, right? I mean, how are we going to do that if we end up with Opera operating out of GCP? What is that, 20 terabytes a day today, and it'll be 40 by the end of the year? Everybody's required then to be in GCP. That's the point of the get everybody in a room together. Is it's unsustainable given our current models. But of course, that's why the cloud providers are doing it that way. They have no choice. Get here and stay here.